we're going to do some more trig stuff. So take out your notes. I'm going to give you some different properties of the sine, the cosine, the tangent. And then I'm going to, well, take this triangle, A, B, C, and say that's 3, that's 4, and that's 5. Alright, take a second and figure out the sine of A. Now, remember, for the sine, if we're going for the sine of A, which one is our hypotenuse? It's either the 3, the 4, or the 5. 5. The hypotenuse is always the longest side. So this is my hypotenuse. Now, when we're talking about angle A, what would BC be? It's the opposite side. And so this guy over here has to be what? Yeah, the adjacent side. So now you can figure out sine, cosine, and tangent using SOHCAHTOA. So go ahead and figure out what those ratios are. Alright, so I know you guys are furiously writing, but what's the, for the sine, it's opposite over a hypotenuse. What's the opposite side? 3. The opposite side is always going to be the farthest side away. And the hypotenuse is 5, so we put a 5 there. Now, for the cosine, the nice thing is once you figure out the sine, the cosine's going to just be the other side that you didn't use. So it'll be 4, and it's over the hypotenuse, which is 5. And the tangent is the opposite side over the adjacent side. So the opposite side was 3, and the adjacent side is 4. Alright, now, for the sine of B, when we start looking at B, actually, sorry. It should be C. Because we're not going to deal with a 90-degree angle. Usually it goes, when we do this, I'm sorry, it goes, I usually put A, B, C instead of A, B, C. It's early. It's Monday. What do you expect? Well, I expect better, but that's okay. If we're talking about angle C here, this is now opposite of angle C. And what would this side be? Adjacent side for angle C. So my sine is still opposite over hypotenuse, but for angle C, what's the opposite side? What's the value? 4. So it's 4 over 5. So now for angle C, the adjacent side 3 and the hypotenuse is 5. And the tangent is now going to be opposite, which is 4, over adjacent, which is 3. Now, take a look at these values. What can you tell me? What do you see any patterns or anything like that? Anything special? Anything equal to each other? Yeah, they're not exactly opposite. They're what we call reciprocals. But you were right. They're switched. They're flipped. So one thing we see. The tangents are reciprocals, 3/4 and 4/3. Now, if you look at the sine of A, is there any other of the 6 things that we found? Are there any of them that are equal to the sine of A? Yeah, the cosine of C. What about the cosine of A? Is that equal to something? Yeah, that's equal to the sine of C. And this is true for all triangles, for all right triangles. The sine of acute angle 1 is equal to the cosine of acute angle 2. And the cosine of acute angle 1 is equal to the sine of acute angle 2. Now, why can we say that? That's my big question next, is why can we say that? How does the opposite over adjacent become, or opposite over hypotenuse become an adjacent over hypotenuse? Well, take a look at A. A is the 3 is the opposite side for A, but what is it for angle C, the other acute angle? It becomes the adjacent for that. Just like this side was the adjacent side for angle A, but it's the opposite side for angle C. So because they flip-flop as far as opposite and adjacent goes, and since sine and cosine, one deals with opposite, one deals with adjacent. Since these flip-flop, this sine and this cosine becomes the other sine, this sine becomes the other cosine. So you get a little flip-flop there. So that's just one of the things that you're going to have to kind of remember. And also, you want to talk about values, the sine and the cosine are always between, they're always going to end up between -1 and 1. So basically the sine never gets bigger than 1 and less than -1. So it always stays in there. So it's always a fraction unless it's equal to 1. The tangent can be any number. Your answer can be any number. Now, for right triangle trig, which is what we're going to do. This is for any angle. You could take the sine of an angle that's like 1010 degrees. And that basically means that it would do a couple rotations around and then get back to whatever value it would need for 1010 degrees. We can figure out the sine for that. But the sine is still, that ratio is still going to end up being between -1 and 1. It's still going to be there. For right triangle trig, when we're just dealing in right triangles, the sine value is going to be between 0 and 1. It's never going to be 0. So I'll say 0 is less than the sine, which is less than 1. And the cosine is the same thing. So it's going to be between 0 and 1. It's never, we don't do the negatives because we're not going in the negative direction. We're keeping everything positive. And the trig values, are all going to be positive too, as well. Not two. Not going to be positive too. They're going to be positive as well. So the biggest thing is, what was that? Yeah, the tangent. The tangent's always going to be positive. The cosine and sine are always going to be positive too. But they're going to go between 0 and 1. They're not going to be equal to 0, and they're not going to be equal to 1. Because these would be for 0 degrees and 90 degrees. And the sine and the cosine we're going to be we're going to be using those for acute angles. So we're not going to worry too much about those. So if we go back just really quickly to these two problems right here. It says, can the sine of an angle ever equal 2? And I know I didn't tell you about what the sine could equal, but can we ever have a sine that's equal to 2? No. The sine only goes from -1 to +1. So it can never equal 2. So that's one of those values that, one of those ideas that I didn't tell you about, but I wanted to see if you guys could figure it out. And if you didn't, it's okay. But also remember that the sine is equal to the opposite over the hypotenuse. And it's always going to be equal to the largest side and a smaller side. And if you have it's smaller. Just try. Now, if you have a number when the denominator is bigger than the top number, is that ever going to be equal to 1 or bigger than 1 or equal to 2? If you have a small number over a bigger number? No, it's always going to be a fraction. So that's another way that you can look at it. The hypotenuse is the longest side in a triangle. And all the trig, even the sine of 1010 degrees, like I told you, still going to follow opposite over hypotenuse. There's a right triangle for that angle as well that we can build. It's always going to be a smaller side over a larger side. The biggest it can get is at 1. Now, we'll talk about that guy in a little bit. Probably not today, though. So, alright, that's part